because you prepared a PowerPoint in particular to address some of the questions that were coming up, and so I'll just give like just a few minutes of introduction to Len, not to him personally, who I greatly admire all his work that he's done over the years with systems. But for this particular, so he's had this USSO, which you all know because it's appearing on many of your presentations, PowerPoint slides. We've seen it before in this. And we've had some discussion about it before, a good discussion, but I thought it would be worthwhile for myself. This was coming out of me, but I know George was going to be interested and Lynn was going to be interested, and you know, you've all been talking about these issues of what's the sequence of systems buildup or systems emergence from the Big Bang into culture. What are various approaches to it? And I've had an approach that you've seen that has these 12 steps of combogenesis, in which I don't try to do all important emergences. I'm just trying to limit myself to ones that build up in a nested way to human societies. And George has his ontogenic cycle, which has some, in terms of the inner core of it, you know, almost one-to-one correspondence with what I have, because he was using a similar logic of building up from prior existing things into new things, new systems. But George is also saying, you know, the emergence of stars and ignition of stars is somehow going to be in his logic as well. So he's got a little bit more of a nest, of a network, not a nest, a network of nestedness, but there's simultaneous scales going on in terms of size. And Hillary, we've seen, has been, you know, wrestling with this issue too, of how do you combine the sort of a micro buildup and a macro buildup and correlate it to sciences buildup. And Tom, there's been a lot of emails about can we classify these emergences that happen within a system versus the emergence of a new system, and how do we can we make various logical types? So to get to Len's, I had a PowerPoint of Len's, and I knew we all know his is many more than my 12. His, you know, 3 or 4 times the size of, in terms of these key emergences. I think it's even more than George shows in the diagram in his book, but I haven't counted yours, George. But the thing about Len's is that it is a sequence. He is positing a single sequence, so it's not a network of things happening, and it's much more than my 12. And so I took one of his, it wasn't from I think it was a PowerPoint, but it was from a PDF, Len, and I actually took the names out of it. It was like over maybe 8 or 9 actual pages in which he has this wave that you're all familiar with of an ID cycle, the integration going up, and then the differentiation, or another word, going down. And in this integration and then a differentiation are in a cycle during these emergences. So I put them into a list because I wanted to think about them individually in a single list where I could look at the whole thing. And I sent it to Len, and I said, is this, and I was thinking maybe we would do some peer review, some peer discussion about it in this meeting. This was about 3 weeks ago, I started this. And Len said, no, that's not what I'm currently, that's one of them, but it's a work in progress. It's not the one I'm currently using. And George had pointed out to me, George was using a list from one of Len's spreadsheets of key origins. And it wasn't a list, it was about 40, if I recall. I decided not to show them today because you can imagine them, in a way you've seen them. And we're trying to get at the basis here. So I asked Len, is this your current one? I said, one difference I see is not just that it doesn't exactly correspond. It's a work in progress, Len said. And it's a science. I mean, I'm using, it's a research project where I'm trying to distinguish these. But what also struck me, besides that they did not exactly correlate, is that in the spreadsheet list of these key origins, he didn't, it wasn't in terms of an ID cycle in which the integration was named and the differentiation had separate names. It was not there. But he is, so I said, is that still one of your key criteria? And we started getting into this issue, what are your properties, Len, that you're looking for, that you're using to develop this sequence? Because I personally want to know if he's got if there's a sequence of, or even a, well, I'd like to know, and I accept that what the sequence is a work in progress. I like that very much. There's a work in progress. So what Len and I were talking about, and some of you were in on some of these emails, got CC'd, and it wasn't to include everybody or not include anybody, but it was just sort of me trying to figure some things out with Len. And at one point, Len in an email said he's after what he called big E, big emergence. Okay, absolutely fair enough. And it's going to have a set of criteria or properties or characteristics of what determines these big E's that are going to be put into sequence. So that's once that got done, I was really happy that would be a great topic for discussion, because Len said he would address exactly what are these, these biggest emergences, and what are the characteristics, not what are they, but what are the characteristics that they would have in common that one in a research program could use to then develop the sequence and try to have some convergence among us about what the sequence is. So what he said, he would be glad to put together a approximately 20-minute PowerPoint about this big E emergence, and we'd be happy to take questions about clarification during it. But if it looks like it's going to be longer discussion for after the PowerPoint, then we leave some of the bigger issues for after. So that's all I would have to say, and I hope that's clear enough as an introduction. And I'll turn that over to Len. Thanks, Len.
Okay, I'll share the screen. The host is disabled attendee screen sharing, so the host is Gary, and so I have
Go ahead.
Okay, so now I can share screen. Okay, so share, and then I'm going to have to minimize that in order to do the screen share, I guess. Let's see, minimize that. And let's see, integration squad. Are you seeing it?
Yes.
Yes.
Okay, so I'm ready to begin. It's only 8 slides, so it should go pretty fast, which is unusual for me, of course. This is an informal presentation, actually, because it's answering Tyler's direct questions today, okay? And it's an inquiry into the unbroken sequence of systems origins. It's also going to end with frequently asked questions, which James Martin sent me, which I think are relevant. And it's both on the systems processes theory and the unbroken sequence of origin. So these are the questions that I think, Tyler, and you can correct me, the definition and logic of the big E. I want to say at the very beginning, the big E is what Solito called it when he observed these things, to distinguish it from all the other definitions of emergence which exist in the literature. So big E is the designation by Hilary Solito. I want to emphasize at the very beginning, although Tyler has done it already, that this is a research project. It's not a product. And so is the systems processes theory, a research project that might go on for 200 or 300 years, not a product, okay? This is because it requires much more research and going into the future. And I will try to explain the methodology later on. What are the major objectives of the USO USSO project. That's what Tyler asked. I want to explain in terms of disciplinary experimental results how one scalar level emerged from the immediate earlier one for each scalar level. So this means neighboring scalar levels, and this is usually a disciplinary enterprise. It's not a transdisciplinary one, and that's where we reside as systems people. I want to map as another objective of the USSO project where both TOEs occur. And this is the theory of emergence and the theory of everything, which the physicists so far have taken over, and they talk a lot about the theory of everything. And I want to explain or prove in steps why the unified theory of emergence occurs. That's another major objective. And while doing it, there are 7 new isomorphic systems processes that are merged, and these are counter parity, the words concrescence, metacrescence, central stability, peripheral instability, neutralization. Roots is a newer one, and then those TOEs 1 and 2. These isomorphic systems processes only emerged after the 1980s, when I presented this for the first time as the incoming president for ISSS. So that's the topics we're going to cover. Let's go to the first one, the definition of, or the logic for big E's in Hillary's terminology. My definition of emergence and its significance, that's what the big E is. It really talks about origins, and in general systems terms, there's been a lot of interest in ontology. And I, because of my biological background, probably prefer ontogeny to ontology. Ontology is the study of the beginnings of individual things or entities. Ontogeny is the scientific study of how they came to be. And we have a lot to say about that in biology because we've studied it for a long time. So I prefer that. So there are many definitions of emergence, from Kaufman to many other people. My intent is to avoid conflicts with those established definitions. It's unnecessary because we're talking about the big E's and only the big E's. So we're going to add just a new one, which is called emergence origin of a new scalar level. That essentially is the big E, the emergence origin of a new scalar level. I can maintain that emergence is not Darwinian evolution. Now, Tom just sent you an email, but I disagree with his universal evolution. They're expanding the concept of bioevolution to universal. That's a new thing. And Campbell, just one article, I've studied books and articles for maybe 30 or 40 years because evolution was my main teaching responsibility. And I don't follow just one article or some quotes from that article because it's now come about. I might say that when I use the word evolution in a AAAS, American Association of Advancement of Science lecture, the astronomer physicist who was there disagreed with me. He says, we've been using evolution as a word long before you did. We talk about evolution of stars and so on. And yes, there's certain stages to evolution of stars, but it's a totally different mechanism. So this conflation of terms is one of the big evils of our enterprise of trying to do systems as far as I'm concerned. And anyway, I maintain that emergence is not Darwinian evolution. And you have to consider the whole sequence, not just some localized events, because it has a different mechanisms with completely different steps, a different time scale, because when you're talking about the evolution of a star, you're talking about billions and instead of millions of years, and it has different subjects. So the different mechanism is quite different from the usual 7 steps that we talk about in Darwinian evolution, which is limited to and encompassing the genomic architecture. So there's different subjects because we include the physical and socio-technical systems. Now, I mentioned when Tom sent us this notice just now, It's from an article of people who in evolution are expanding evolution, but I would have to say that that conflation of words is an error, and I will maintain that in the long run. Continuing with the definition of logic of Big E, which was one of Tyler's major questions. Tyler, are we answering your questions?
Yes.
The criteria for what is and what is
Well, then,
not a Big E emergent level. This is a direct answer to what you're asking, I think. There's an origin of a new architecture or corporate plan. I call it corporate plan, which is German for body plan, because I don't want to get mixed up with the old words and the baggage that encompasses and follows on the word structure. But basically, we're talking about a new structure. It's marked by spontaneous emergence of new dynamics. So when you go from individual atoms to compounds, you're talking about things like covalent bonding and ionic bonding and other types of bonding. You're not talking about that which holds the individual atoms together and characterizes their corporate plan. And so there's appearance of a new architecture or mechanism for that architecture. And this results directly from the diversification variation. So the word you were searching for ID is diversification. So it arises from the diversification variations kind of spontaneously. That's very important that it does it spontaneously because it's non-teleological. And so I also would think that the Big E would be associated with a new counterparity, a major symmetry that appears for the first time with this new corporate plan. Now, have I identified the counterparity in each of the Big E's? No, I have not. That's why we say it's still a research plan. So the new corporate plan actually initiates a new dynamic. So when you go from elements, for example, to compounds, you're talking about sharing electrons in the outer shells, and that's the peripheral instability and central stability, but it presumes the central stability already. So the new dynamics is really based on the counter corporate plan, which is based on the new diversification variations. So the theory of emergence is the arc of integration for each level from the diversification. It's repeated at different scales, and of course that means high abstraction is required, which weakens our arguments because we have to abstract from the neighboring levels. But the origins of new assemblies does not start from the smallest to largest, I found when I did my systems allometry empirical work. It actually starts simultaneously at the opposite extremes. The very, very large things in the universe, like the cosmic microwave background and the clustering of stars and the clustering of galaxies even before that, starts at one point, but at the same point in time, in the actual absolute time, the minor things, the subatomic particles emerge from the quark soup and become stabilized into hydrogens and heliums. And only after that do you have then the, then you have the human levels, which are in the middle in terms of mass. And it explodes then because of human beings' creativity. It becomes exponential at that point and results in lots of different new levels of things like different philosophies and different religions and so on, and different socio-political organizations. So the methodology behind the USSO, and we're almost toward the end here, it's informed by many scientific reprints. I've collected more than 2,000, and I've collected them from peer-reviewed research articles from major journals. They're organized by scalar level and transition, and I didn't include the slide here, which is the pictorial of my files, but I have something like 60 files organized by scalar level and that particular transition. because what I'm looking for is experiments that are reported in the peer-reviewed literature, which then give information on how one level emerges to the next. That's the thing I'm trying to get at, is informed by the scientific research. And I honor and cite much past work, Desjardins, Barrow, Peebles, who just got the Nobel Prize this year, Morowitz and Smith, you guys know. Lovejoy actually started with the words grand sequence many years ago, although his is Aristotelian and pretty fixed, not dynamic like ours. Miller and Urey, who started off a lot of the origins of life research. Miller actually got the Nobel Prize for that. Margaret Burbidge, the woman, it was a husband and wife astronomers. Margaret Burbidge just died this year. She was 100 years old. Chasen, Bejan, Christian, who Tyler knows, Kaufman, and then I include a lot of our work at the very end there. We're coming at the very end, though. A lot of people have been working on this for many, many years, and we should look back at what they did, because most of them were doing cosmology, some only adjacent levels. So when I did my 1985 course at the UC San Diego with the Burbidges and Miller involved, Peebles and Barrow and these others weren't there. Of course, Desjardins has been dead a long time. They only talked about adjacent levels because they were real university professors. And they didn't talk about the USSO per se, but I did. And I organized the entire course as a USSO course where I juxtaposed the various level people and how they explained going from one level to the other. I might mention that Burbidge, besides dying this year at the ripe old age of 100, wonderful lady, actually was the one who described how stars in their interiors have all the characteristics needed, or criteria or energies needed, and densities needed to create many of the other elements, all the way up to iron and so on. So the heavier elements are made in the star cauldrons. So basically, Burbidge and the others were disciplinary people who were talking about specific things. Like Miller and Urey, I might mention, in the Origins of Life experiment that they got the Nobel Prize for, assumed a reductionist atmosphere, but geologists and physicists have changed that since then and say there was no reductionist atmosphere. I don't know what's happened with the oxygen revolution. That was a big revolution, and that changed things quite a bit. And so even the Nobel laureates we can't rely on for the final word. So anyway, these were virtually non-systems levels. The USSO concentrates entirely on systems, but it links them to traditional sciences, and that's what I wanted to do. So the USSO is abstracted to the systems level and focus, which all of the above works were not. They did not emphasize the systems level. But I think Mobus and Tyler Volk are interested in that, even if they don't declare it. That first paper I did in 1972 emphasized that hierarchies arose from field axioms, but lately I do not pull in the axioms or the systems processes as much as I used to, unless you look at the general systems life cycle, which talks about how the various isomorphies portray the various steps in the life cycle. So I'm only 2 slides away from, so why even do this number 1? I have 2 slides in this. It's what reductionist scientists do. They talk about how one level can give rise to the next. However, this group, although transdisciplinary, has to recognize that interdisciplinary has always had a very bad reputation in university circles, and there's practical reasons why. When you go up for tenure, your committee looks at journals in your discipline. It does not look across disciplines. There's a certain disciplinary tyranny of those tenure track, and I used to chair a lot of them and respond to them because I was department chair. a person's reductionist reputation and entire CV is a wholesale rejection of going across disciplines. However, there are things like biomathematics and sociobiology, which have been around for a long time. But actually, if you work in biomathematics, you should know, or probably do know, that it has been rejected by both biology and mathematics for a very long time. And remember, there were a lot of biologists who objected to sociobiology when it came out by Wilson. So we do transdisciplinary things, but this is even weaker than interdisciplinary, even though they still happen and have a good reputation in biochemistry, bioastronomy, molecular biology, systems biology. And there's other ones like astrophysics, cosmochemistry, astrobiology. And I even gave papers at a bioastronomy conference, which was allowed by the astronomers in order to do my giant planet origins of life proposals research. G-pools means this is ridiculous that the NASA people look for water and DNA on other planets. It's ridiculous because there are other ways in systems terms of getting what water does on our planet and what DNA does on our planet that could be silicon-based in a giant planet which has much stronger gravitational and pressure fields than we do. In fact, I propose that we do the Miller-Urey experiment with diamond anvils and so on to try to contain an atmosphere on our planet, which imitated the giant planets like Jupiter and Saturn. And as many of you know, there are many more giant planets than there are cold, hard rocks like Earth is. So NASA looking for aliens with just our parameters are stupid, frankly. And so are the movies like Star Trek and stuff that all have multiple organisms of some sort that have eyes at the top and are basically bilaterally symmetrical. This is just shows how small human minds are. And if we have trouble accepting people who have different colored skins, think how we're going to have trouble when we meet other alien ecosystems. So anyway, it's accepted interdisciplinary, but mostly only for neighboring interface disciplines. They don't like going across all disciplines. That's something that has to be proven as a point yet, and I'm very sensitive to that. So one very important point for each level to level transition in the USSO, I usually offer 3 to 5 possible experimentally proven alternatives. For example, the origins of polymers, to explain how one level came to the other, like the origin of life polymers, and the first cells. I usually use coacervates, lipid vacuoles that are made on the ocean, clay deposits. I mean, there's several ways that you could have gotten the first metabolism started by concentrating things. Operons, coacervates, Fox microspheres are very important. The same thing for universal clustering, like the clusters of galaxies, the clusters of stars, and the clusters of stars. Several possible experimentally proven alternatives increase the probability of scalar to scalar emergence as more alternatives appear. So I try to, as level to level in the USSO, explain several things. And so why even do this? To see the whole USSO for the first time from completely systems focus, and to move to a systems orientation where there are no chasms between all these spheres, like the chemosphere, geosphere, biosphere, sociosphere, culture sphere, if you will, noosphere. Consciousness could be thrown in there too. But there's more of a continuity between the levels, than this huge chasm that humans have set in order to make themselves separate from animals. And also to see the 7 exotic new ISPs. And I talk about 2 TOEs, the theory of emergence and the theory of everything, which is non-mathematical. And even Barrow in his book on the recent theory of everything actually moves from mathematics to the fact that the systems level might provide some ideas which are important, as important as the mathematical foundations in quarks and other things. And also, of course, it provides, Gary Smith might be interested in this, a major cycle or oscillation in the ID cycles that you can add to the relational database. So there's many other cycles there, but this one would show across all of the scalar levels. And to broaden the science disciplinary approaches, as I mentioned, the University of California, San Diego experience, they only did their level-to-level transitions, which were allowable as good scientists like Burbidge and Miller and Urey. But I was the one who did the talks on the theory of emergence in that series and brought them all together. It didn't have a huge impact on the students because they are pushed into the reductionist pathways and have to do that in order to progress in the tenure removal thing. So anyway, I wanted to provide links to the scientific literature, or otherwise we would be overwhelmed and ground in these transdisciplinary notions into the scientific literature. Otherwise, I don't think there's a little chance of converting them, only providing for a new audience that has that level. And this is the last side. James Martin kept getting questions about the systems processes theory. And so he asked these questions that I should answer. What was the motivation for? What problem is being addressed? What questions can be answered? What are the premises? What is the avenue of research? What are some of the key findings? And what are the elements of the theory? What has been done to validate the theory? And where can I get more information on the theory? And I end with those because I think they're very good questions, and I'm writing one of my 60 pamphlets on those right now. Okay, that's the end of my presentation, so I'm going to stop sharing and get back to all of you. Did it answer any of your questions, Tyler?
Len, it was exactly what I had hoped for.
Good.
In terms of your setting up, yes, in terms of answering the questions, and I think it leads to a lot more from everyone. And what I was hoping we would do is sort of like that happens on that other Saturday meeting, is to make sure everyone has a round. And I'm going to take the first one, and I'm going to try to keep it short. I just want to do I really want to hear others, and I'm sure others want to hear others also. But one thing I got, Len, is that your big E, it's not necessarily from mergers the way my combogenesis logic is, where I'm trying to restrict it to the combination and integration of prior existing things. And I'm going to guess that's pretty close to George's ontogenesis as well. But yours is not necessarily from a merger. You could have a new big E happening within a cell, let's say the Golgi apparatus, or the a certain organelle that's not the. I know in some of your lists you had the nucleus. I just want to ask you the question: is it always from a merger or not?
No, in fact, the USSO recognizes subspecialization as a hierarchical strategy, as well as combogenesis, you might say, or ontogenesis. So subspecialization is a clustering also, but it is not a clustering by what you call merging.
And just one follow-up from that to be clear, and then what you would hope for when you do the subspecialization is still a way to define it as a new scalar level in big E, as opposed to other subspecializations that might have happened within, let's say, a multicellular body, or within a human society, or within a living cell. Is that right?
I wouldn't allow myself that conclusion yet. I would say that it's still under study, because the subspecializations might not lead to a big E. they might lead to what we subsequently see as a hierarchical level. And I might add that Mandelbrot, who did fractals, says that Zwicky was wrong at Caltech when he described mergers of large combinations of things in astronomy as hierarchical levels anyway. He says they should be called fractals. And, you know, he's a pretty smart guy, and I think he's partly correct. I think what we term hierarchical levels in the natural world nowadays could be called both hierarchical levels and fractals. And then that confuses the issue on what do we call a scalar level then, or an emergent level. And that still has to be studied. I'm sorry to dissatisfy you, but I'm not ready to make a conclusion on that yet.
So I'm gonna move on. So so everyone's gonna have maybe hopefully several rounds today, and I'm just gonna go sort of clockwise in my screen. I don't know if it's everybody's screen. So it's gonna be, if you don't, George, Lynn, Kurt, Hillary, Helen, Tom, and Gary. If you don't mind me taking initiative on this, Gary.
No, it's always good. Thanks.
And you can always pass and just wait for another round if you want also. But George, if you want to chime in.
Thanks. Okay, thank you, Len, because we're getting a little closer to, at least I feel I'm getting closer to understanding what's behind all your work. I just wanted to clarify one thing. Tyler had brought up that I have a diagram in the new book that shows all these things going on sort of in a network form. The purpose of that is because I put a lot of emphasis on coevolution. And I do disagree, Len, that as long as you say Darwinian or biological evolution, you can differentiate that from physical evolution, from cultural evolution, and so forth. So I do use that term. But the idea is that these things are all connected. And your idea of the fact that big things came into existence at the same time little things came into existence, I'm not quite sure I follow that reasoning, because the Big Bang gave rise to the smallest things. And it wasn't millions and millions of years, if not billions, before some of those bigger things started, the hydrogen clouds started coalescing into stars, and then the beginning of nucleogenesis. So anyway, my point is that coevolution is kind of important to me, that all of these things, stars had to exist in order for planets to be able to acquire energy and so forth. So that's why the network. Also, in that diagram, I do have sort of dotted lines implying that there were other things in between. And I was trying to get as quickly as possible to the human social situation. So I'll stop there, I think.
Oh, okay. Oops. Sorry, I hope that's not a bad echo.
Oh, so Lynn next, or unless Len wants to answer something to George right now, or elaborate on anything right now.
Well, I can wait, but I want to say that I emphasize that all systems are networks, and all phenomena, natural phenomena we look at are systems. So in that sense, we're close, George Mobus and I, in terms of emphasizing networks. It's just that I don't emphasize them as much for the USSO. And I have to think more about the coevolution. I kind of agree with the fact that several things were required as the matrix before and during the progress of the USSO. Okay, that's I can talk more about those later. And I do have notes here. I'm taking notes on everybody.
Lynn?
Beware. Lynn is next.
Yep.
Lynn, are you still with us?
Yeah, I'm here. I'm here. I had to unmute. Yes, I'm taking notes furiously too. First of all, when I believe that years ago when I first started listening to you, Lynn, that you were calling this, instead of the big E, you were calling it origins as
Yes.
your process. And because emergence is so commonly used, it's just, it's commonly used as emergence of any combination of things emerging to the next level within a hierarchy. It was interesting to hear you say, to talk about fractals and hierarchy. I've run into it in writing the field guide. I'm writing the same things. It's interesting to break everything down and actually write about the different systems processes because these different things came from different like control theory and evolution and information and chaos theory and network theory. I'm finding these different theories. When you actually start writing about systems processes, you start getting a more, I start having the capacity to assess what's going on in the different theories and compare them, because people come from that particular that point of view of say systems dynamics or network science, and they get to things like fractals. They get to, you know what I mean, in the development of their things. And you brought it up with evolution of stars. It's not evolution of stars, it's development of stars. Evolution, then George, I like coevolution very much, and evolution, I have to put, again, in over the years, I always wanted Len to cover evolution and development a little bit more. We just never really covered that very much in any of our courses. When we sat down to, a bunch of us would get together and work out and contribute, read up in the literature, and then contribute into the features and functions and definitions of a particular systems process. Evolution and development were never one of those processes that we covered. I think then there's so when I look at origins, emergence, the big emergence, big E, and I look at evolution, when I'm looking at how I'm going to write this section in the field guide, which I haven't written, I've got loads of notes, but I haven't written. How am I going to write about that? Where am I going to, how am I going to put that all together? What are the features and the functions of each one, and how do you separate those out? And until I see those actually I want to see those discriminations, is what I guess I'm saying. I want to see the features and functions of evolution, development, and origins or big emergence, or whatever you're calling it. That's what I want, I guess, in the end. That's where I'm getting. Enough. Does that make sense?
Mm-hmm. I have discriminate and distinguish evolution versus development. And I have two ways of looking at that. Unfortunately, those two words are very big in teaching biology. And so my tendency is to discriminate them based on what happens in bioevolution and what happens in biodevelopment. So bioevolution is very open-ended, but biodevelopment is very closed it's already determined a series of steps that has to be gone through. And that's one of the major differences, I would say, between systems evolution and systems development. They may be different things. And I agree with you that the stars really should be called star development, not star evolution. But we're not going to change them.
Right.
They were doing that before we did it. So I don't know what to do about I often used to say, and Jack Ring loved it, that science progresses mostly by the cemetery. The old guys have to die off, and their minds and their baggage for various words have to be gone before we can get to the new definitions. And it's kind of true, not entirely true. And that looks at Kuhnian paradigm shifts and stuff like that too. He kind of proved that it has to happen by the cemetery. Amen. So anyway.
Well, the Evo people make a big, there are Evo Devo people. I have 3 books on it right here who are making a big argument that there is no difference.
Yeah, I disagree with them.
And so it's you know, it's interesting to parse that out. But that's, you know,
they're trying to make a
the
new
whole thing in itself, the whole research project.
And it is true that evolution proceeds by developmental changes. That's what happens.
Exactly.
So it's pretty hard to argue against them and discriminate those. But that's a good point. And there is that entire squad. It's a bigger squad than ours. Let's go on,
Thanks,
Tyler.
Kurt.
Oh, okay. Well, thanks.
Hillary,
It's great.
Hillary after.
And I don't have any really good questions. So, well, but there's a request, because I have not seen an updated diagram of the sequence for a while. So if you can mail me one, or if other people want to see it, you could display one or something, that'd be grand. I really like the metaphor of corporate plan. I've been looking for a way to use that better as a tool for my students. And I really, you know, I like the term strong emergence, you know, a lot. I'm sure I'm not the only one here who uses, you know, the example of water, right? As when you try and explain emergence to a student, that, you know, there's, even if we start with H2O as a molecule, right? Then you can claim that that's an emergent level, right? Among, you know, the elements. But, you know, there's nothing in that indicates the properties of water, and there's nothing in the properties of water that necessarily indicates the properties of ice or snowflakes, and you go on, and flow is in there, and of course then turbulent flow. So I think, yeah, I don't have any great probing question, but I appreciate your comments, and look forward to seeing more about it, I guess.
Kurt, I like the fact that your hat does not have MAG on it. And I take your point about the request for USSO. I have now decided to do pamphlets, which will be available on Kindle. They'll be 30 to 50 pages each on each of the spinoffs, and I consider USSO one of the spinoffs. So there'll be one on USSO. But I was flummoxed lately by the request of Peter. What he wants is not a 30 to 50 page exposition of each of those, which could be chapters in a book later, but in fact, he wants a 1-page précis of the whole thing. So I'm doing those too, and I'm doing outlines for my students starting January 18th so that they can, so I will send all 3 to you when I get them done, okay? When and if I don't die before I get them done. We're all getting a little bit old, except for Tyler and Lynn, of course, and Gary.
Pauline.
So Len, before we move to Hillary and then Helen, I guess the most updated version is that one in your spreadsheet that's the 40, but that didn't have the ID cycles. And I guess I could just repeat to the group that this work in progress aspect that you deferred giving us for this Saturday a USSO that you wanted to defend every step in that sequence. You deferred that request.
Yes, I deferred to defense.
So
there's enough of that going on right now.
Yeah.
However, I continue. What I'm doing now is collecting these reprints, and I have to study the reprints too. So the first steps first, and the next step will be the Excel files on those 2000 origin papers, and you'll be able to go through the titles and pick out ones that you particularly like. Like I have lots of things in those reprint files, like I've divided up all of the Earth's major things like crust and magma and core and mountains, and I divided freshwater from oceans and so on. So even freshwater itself has rivers, lakes, and so on, right? So those may not be levels, but they may be informative of levels. And so that's why I have to collect them, and that's what I'm doing. So the next thing would be the research project background, relational databases, I guess, or databases.
Thanks. Hillary, and then Helen.
Yeah, so thanks very much, Len. That was very useful. I'm getting an awful lot of input today. I got halfway through Tyler's book a year ago and then got diverted. And so today I've been reading about alpha kits and sorry, I've forgotten the name again, the domain.
The dynamic realms.
Dynamic realms, yes. And I like that description as the system architect bit of me likes big architectural chunks of a problem area. And I like the scalar level. I think I'm trying to get my head around scalar levels now, and I'm not going to ask for more explanation today. I need more time to absorb, because I think a lot of these ideas that have been swirling around are beginning to crystallize, and I don't want to kind of over accelerate that process. So I'm listening more than I'm talking. One of the things, I mean, coming to water and rivers and lakes and things, one of the ideas I'm trying to get my head around, and I'll say I'm not an academic, so I don't care whether what I say gets published or not. And I don't have a career to worry about. So I can take the luxury of philosophizing and thinking and spending as long as I need to understand what I'm interested in. But you get atoms to molecules is quite a clear step in I guess it's different scalar levels. But then a lot of stuff starts happening. We get the complex molecules up into biochemical systems, up into biological systems, up into cultural systems. All that can only happen in a context of a planet, I think, which requires there to have been gas clouds and stars and stuff breaking up. So you've got to create the higher elements before you can start having useful biological and probably geological evolution. So there's a kind of astrophysical and geological dynamic realm, and I'm not sure if that's one dynamic realm or two. And there's a sort of ecosystem dynamic realm that says I need some sort of ecosystem for the more complex biological systems to evolve in, and they in turn influence the wider geophysical or geobiophysical ecosystem. And I've got this picture of lots of glorious complex interactions happening, and we're seeing seeing fragments of structure, of how to structure a description of that. And if we try to accelerate the convergence on that description too quickly, then we kind of break things and we miss things. But so there's something crystallizing out of a multidimensional soup of these ideas that I think is very exciting. But I'm very worried that if we push too hard too quickly, we'll break it. And if we don't push hard enough, then we're never going to get this concrescence, perhaps, of a better understanding. So I'm basically just trying to absorb this without perturbing the process too much at the moment.
Well, you've already influenced it way much, Hillary, by two things. First of all, the big E emergence designation came from you.
All right, I didn't even realize that.
You don't remember it, but it was after looking at the USSO that you decided that there may be, you didn't commit yourself, but there may be a big E emergence. And then your recent concern over scalar levels is important to that. That is something that has to be examined in allometry, and I don't have students anymore to do the slave work, but when we say the word level, we usually imply hierarchy, and when we use the word scalar, we imply measurement. And the third thing that you came up with that was an insight, there's three I'm crediting to you, Hillary, was that for the first time as an engineer, you got out of the human realm and kind of discovered, or maybe temporarily said, well, maybe there are a lot of other systems besides humans. Engineers tend to think in terms of humans because that's what they're focused on. And they grow up with their minds modeling the world in such a way that they don't think of the natural world. And that was a big revelation to me, that you discovered that there may be systems out there. And I thought that was tremendous. That was a tremendous advancement. And I wish I could get engineers to think that too. Anyway, those are the three I credit to you, whether or not you want me to. And I think we need to look at the scalar levels more. I think we'll see that there are different complex interactions for different scalar levels, and that characterizes the scalar levels. That's what I meant by, in my PowerPoint slides, that line that said the mechanisms differ, or the dynamics differ as you go from level to level.
I mean, to be fair, I think this thing about recognizing systems outside the engineered world, I think a lot of my peers in the UK would not find that at all odd. And indeed, people in ecology and all that sort of, what's his name? Lovelock is British after all. And he's had a huge influence. And Derek Hitchens, again, the way he describes, that's interesting, because the way he describes systems, to me, he was describing systems that didn't need to have people in them. And then he's, we have debates which I'm not quite sure where they're coming from and where they're going, but let's put that aside. I've learned a lot from Derek and others, and a lot of this stuff, I suppose a lot of this stuff that seems obvious to me doesn't seem obvious to other people, but I'm glad it's obvious to a few of us. I guess that's why this group is communicating so well.
I noticed that whether we're talking about combogenesis of Volk or ontogenesis of Mobus, we really agree on the fact that there are other systems in the world. At least we can look at the systems level within our little integration squad. I just warned the group that this is very, very much against the dominant forms that are in the world. Because we have to remember that when we go out, we can't be expected to be accepted.
I think that's changing quite quickly. I think a lot of the environmental awareness, certainly in Europe, is and the economics that people like Kate Rayworth are doing, that's all system oriented. I'm finding, I mean, the First Minister of Scotland is using the word system correctly in ways that very few politicians would have done 5 or 10 years ago. Not many do now. I feel that the tide is beginning to move in a direction that makes me feel less weird than I did feel. But,
well, I agree with you. I mean, we have systems biology, systems chemistry, systems medicine, systems genetics, systems immunology that are recognized per se, even systems pathology. So I agree with you, but even those people are not accepted in their fields. The systems biologist, one of my colleagues told me, systems biology is just a fad. It's going to pass very quickly. And he became an enemy of mine, or he himself decided he was an enemy of mine on my own faculty for many years, decades.
But see, I have to step in here. Every single issue of Nature and Science has dozens of articles now referring to networks and everything else, and using data, using all the data management, all is systemic. It's well into the culture. I think that the problem we have now, and I just wrote about it this morning, I just added this little paragraph to my book. The problem we have now is just that everybody out there is learning it from their different associations, there are different points of view, there are different classes that they took from whatever place they took it in. There's no general accepted general course that you take where everybody has the same, there's that you take in high school, saying this is what basic system science is. It doesn't have a taxonomy yet, which Len, you've definitely outlined as what we need. And it could be systems processes. And but still loads of work is being done out there in everything, in all kinds of fields of biology, all kinds of fields of astronomy. And they're referring to networks and hierarchies and certainly feedbacks and all the climate work. I mean, every single, there's plenty of work out there being done in manipulating data in ways that are coming out in articles. I mean, it's so simple for me now. 20 years ago or 15 years ago, when we were doing courses and trying to find examples of these various systems processes, it was very difficult. You had to mine for them. Now it's just right there in every single issue of Nature and Science. I mean, there's just examples all over the place. So it's what we've got is, it's here, it's just a mess. I mean, we don't have a basic taxonomy. It's not well organized. That's what I'm saying. And it's just tools now. And the tools need to be organized, to me. And complexity science, what a mess it is. So that's my take.
Is that not just a characteristic of a domain in very rapid evolution?
Yeah, I think it's exactly what Len was talking about as far as it's I have to look up the words, but we're looking at a chaotic thing going on right now that's emerging. Yeah. It's an emergence system, just like any other emergent system. We're going to have a new basic science.
Yeah, that's good.
And that basic science will have a taxonomy of systems processes. And that's where you'll start in high school. And by the way, NetLogo, I can get on NetLogo right now, and every single systems process I've written about is already modeled in NetLogo, right, Kurt? So I think things have really moved along. They just need to be articulated.
And the students, and I apologize, Tyler, we're hijacking your flow.
No, good.
My design students, they run NetLogo, and I have them modify labels, and I say, look at some interesting things in nature and think how they might apply, to your life or systems, and they do it, sometimes reasonably deep. So yes, it's amazing if you haven't played with it. you should spend a little time. Net logo at Northwestern.
And these students too grew up in a different world than we grew up with. They didn't have to unlearn things. You know, they grew up, my kids grew up, they're in their 30s now, and they're talking about how different the kids were in their 20s now, and then the teens then. How they're thinking very differently. They very much think into, they've watched networks form up right before their very eyes. They know how they work. They form up networks themselves. They see how hierarchies form up. They get it. When you actually describe it, they go, oh yeah, yeah, yeah. You know, they know what you mean. I mean, my son was doing, in 6th grade, was doing object-oriented programming and dealing with hierarchies of, you know, computer science. I mean, it's just everywhere out there. These people, that's how they think. We are behind them. We just have to articulate it. That's what my thinking is now. But anyway, that I diverge.
Okay, thanks all. Helen, you're up with Tom in the bullpen to be next.
Yeah, so I'm a bit in a similar position than Hillary is that every time I hear someone speaking or saying something, or I read an email, I have lots of thoughts that come and I want to respond, but then when I'm ready to, you know, write something, another email comes and another idea emerges, and so I'm never in a situation where I can form some thoughts in a kind of cohesive way. I mean, not to say that it's not happening, but I feel it happening under the, let's say, under the hood. Things are going on in there. There are a few things that I keep coming back, and there was discussions earlier in these conversations on affordance, which I'm not sure if it's a typically anthropomorphic term or if it can be applied to everything, but it seems to me that it's something that can be applied to any type of entity. And so in any form of sequence, and we had discussions about scalar levels and which are they, and do we need to have granular levels or not, but at any given, you know, transition or jump from one level to another, what are the affordances and on what type of variables do they come? So I probably don't have the vocabulary today to say this, but let's say what is gained, what possibilities are opened from one level to another, and what is gained from one level to another, and would there be a simple process that would say there's a gain in a possibility from one level to another on this type of thing, and as things evolve, you gain more, not only more possibilities that accumulate, but more possibilities on a broader spectrum, let's say. And that's where I also come back to the Alpha Kit, that I also started reading Tyler's book and and we even had a conversation with Tyler where I said, oh, I see the Alpha Kit here and there and here and there, and I already forgot what I had thought at that time. But there's something here about information, about signal, about communication. And for me, that could be, this is where I would like to focus. This is what I would like to research, to see if there's something simple that could connect, that could help describe or connect a process of well, I don't know if you don't want to call it evolution, Len, I don't know, or how things move from one level to another, whatever we may call that. That can be then either diversified or integrated. I mean, something that we could even model on, joking, on what's the name, NetLogo or whatever.
Well, I have three responses, Tyler, to Helene. The first one is one of the, in my lectures on field as an isomorphy, I talk about potential fields and constraint fields. And I say, are they real? Because usually potential fields are not realized as entities, as real manifest systems. And for each emergence, and that there's the second one, the diversification is a response to the opening of new potential fields at the new level. And so it's an important way to recognize the difference between the scalar levels, Tyler. I should have added that to in fact, maybe I did. New diversifications happened because of the new integration that happened. And so that is this potential field idea, which I did show as another oscillation where I had all the potential field alternatives underneath an eye, and a human eye saw the manifestations above when the oscillation happens, above what you might call the carrying capacity line or equilibrium line. And the manifestations we see in the world are these other ones, and the potential field is the one you have to see in order to understand the next level of emergence. And so it's really important to the emergence or whatever of the next level. And it may be that those are saying that a new alpha kit is derived for each new big E. So to relate it to Tyler's work, it might be useful to do that. And the subspecialization actually happens because new potential field is opened in order for there to be subspecialization. It's just afterwards we can't distinguish the emergent level from the subspecialization.
Yeah, and it's like a learning process, right? It's like when the possibility becomes realized, there's some like acquisition of something that becomes learned in a way. But I don't know if this word can be applied to I mean,
well, you're into semantics. We don't like to use those words across levels.
I know,
like the word
but
information, because they have so much baggage with them. But
yeah, but if you think of a process,
there are relations.
Yeah, if you think of the process of learning and not the entity or the whoever,
well, I mean,
whatever
the general
is
systems hypothesis is that the same system keeps erupting over and over again in nature, just at different scalar levels. And
yeah.
That's our assumption, so to speak, for the general systems theory. Now, we only have Tom left, I think. Tyler,
Well, you had
right?
two other things to say, no? Or
No,
you said them already? Okay.
those are the three.
Okay.
Well, Tom and then Gary.
Hey, can you hear me?
Yes.
Okay, good. Well, I agree with a lot about what I've had to hear, what I've heard so far, starting with Tyler's introduction and the need for criteria. I think we need to define things better and describe the distinctions that we're making. And I think we're starting to do it, but we need to do it in a more systematic way. And I think starting at a very low level, the types and metatypes that I sent something out, I guess a week or so ago. which goes back to some distinctions that Gary made like a year ago. We still haven't been able to get that completed and decided on, but I think that's a step in the right direction. I agree very much with Glenn's USSO and his focus on the big picture, because I think that's the thing that's missing, putting this all together. And I'm very positive about the knowledge and the insights that we have collectively, which is an embarrassment of riches in a sense. But it's a little depressing to think of how much there is to do and how it's all going to be put together. So I agree with the idea that Len has said today and many times earlier. We need a kind of perfectibility, a way that we can keep adding things and improving things and extending things and keep it all together. And that's the big motivation behind me modeling, is creating an adaptable model that's perfectible. We'll never reach perfection, but it can be continuously improved and extended and allow us to be able to communicate and collaborate much more effectively. Just to comment on the universal Darwinism, I agree very much with Len, what he said. I always saw a difference between Darwinian evolution and system evolution. In fact, I've seen system evolution as being more general, a generalization of Darwinian evolution. So I don't like the fact that the way they use it in this group. But there are some very interesting ideas in there, things that I hadn't seen before, and I thought it's worth looking into. I believe the reference I gave you is to just a chapter of a draft of a book that hasn't been published yet. At least that's what it seemed to indicate on the website. So I think it's worth looking into. Going back to the criteria, with Len's USSO, the thing that I would like to see is to define the relationships better. So I see several basic relationships, which I've said many times, so I'm sorry to repeat myself, but there's the levels of a containment hierarchy. And I think when we say levels, we generally mean a containment hierarchy, but then there's an order of system evolution. And they're similar, but they're two different things. So going back to criteria, we need to define the relationships very clearly, show multiple relationships, which again, I think you can only do in a practical way in a type of model. And I started writing something up on that at one point. I didn't finish. I'll try to finish it and send it out. The other thing that keeps coming back to me is the idea of a strategy. How can we use our time in the best possible way? There's so many things to do. And I relate very much to what Aline said. Each time you sit down to do some work, it's hard to decide what to do. Should you read this thing that looks very interesting and you want to learn? Should you do this practical work of completing a paper or a PowerPoint or whatever? Or should you just take some time to digest everything that you have and think through these thoughts that you've just been waiting to do? And there's just so much to do. So I keep thinking about strategy. How can we come up with a way that is most effective and productive for what we're trying to do? That's it.
Well, I respond to that very quickly, although we're going over time. I'm sorry.
No, we have a half hour if people are staying on.
Oh, I thought you wanted to do all my stuff in 1 hour.
I don't know, Gary. Do we have?
I'm available.
Do we have something
Anyway,
on the
to
agenda?
address the last thing that Tom said, I want to hasten to cite my friend Luke French, who used to be in the courses with Lynn Rasmussen and is the secretary for the Systems Pathology Society, which hopefully you all will join. In any case, he uses the word triage, even though he doesn't like medicine. And I think that's relevant to what Tom is saying. We kind of have to triage what is the next thing to do in terms of the research, because there is so much to do. And I agree with him. And in fact, it follows the systems that are in the USSO. There has to be a central stability, and we haven't achieved a consensus model that we all agree with and can say, yes, this is, I can point to this, this is where we all agree. And that central stability is necessary for any progress to evolve. You have to have that central stability. And that's kind of what the integration squad, that's why I called them that. That's what you guys are trying to achieve, and I compliment that. But remember, the central stability had peripheral instability across all these levels, and that's what leads to the diversification. And in answer to Tyler, I don't know if you ever saw it, Tyler, but I did for the genetic levels, which are many hierarchical levels in biology. For the genetic levels, I did the central stability and peripheral instability that was built on the central stability for you as a hierarchical outline. Did I ever send that to you? I know I didn't finish
I think
it.
you sent it to the whole group, Len,
Yeah.
but
I keep
we had
pestering the whole group with large documents. I'm sorry.
Yeah, go ahead.
Okay, so that's all I wanted to say about Tom. And he's the one who's been holding us together in terms of his models, I think, that are summary.
Gary.
Bye all. I have to drop off. Sorry. Thank you very much. It was
Thanks
excellent.
a lot, Kurt. Maybe
Bye,
come back
Kurt.
again.
Yes. Just
Thank
let
you,
me know.
Kurt.
Yep.
Yeah, so just a moment for me to. I've really appreciated the session and the things that everybody has said. And thanks again to Len and to Tyler for bringing together this overall session. I think it's been very valuable. I still, I still see us hovering between what Len was talking about in terms of establishing that shared model. But I think that what we're also doing is through these conversations, we are making progress in starting to develop a shared understanding of terms and each other and how that would then relate to that potential model. So I do really feel that we're making progress. I made a few notes of things that occurred to me in terms of terms and differentiation. So I really appreciated the discussion again about the difference between evolution and emergence and development. I think that is an important conversation that we can continue to work on. And again, I really appreciate the work that Tom has been doing with the model, because this helps to make things explicit. So I think if we look at evolution, for instance, again, relating it to the USSO and the diversification and the integration stages, I think what I would, well, at least what is in my mind, and I've put this forward for people to think about, when we talk about evolution in terms of, akin to Darwinian, what we're really talking about, I think, is competition in the diversification process phase. If we can see that there is competition in that phase, then we are sound, I think, when we use the term evolution. But I think that term evolution can extend beyond simply the biological. I think that if there is, let's say, competition in that environment during the diversification, then maybe we could use evolution in that sense, in a safe way. I really appreciate the idea of the big E, and whether we can use that as a link to the alpha kits. I think that is important. I think that the big E resulting in the affordance for diversification is a good way of classifying it, because I think if we look at some of the smaller E's, that doesn't happen. The other thing I think that is potentially interesting to think about with that diversification, that is the other side of, or an enabler for that diversification is perhaps, I don't know, and again, coming back to a biological term which might be useful, the creation of a niche, a new space within which diversification can take place. So that might be worth thinking about. There were several points that occurred to me during the call, but I think everybody else covered these, so I'm not going to go into those. But I really do think that we're making progress, but I also acknowledge that there's a huge amount of work to do. So I'd just like to say thanks again for everybody participating in this, because it is helping me, and I think it is helping everybody else.
So in response to Gary, I refer to the work of Peter Corning, who was an ISSS president, and Herman Haken, who's getting too old to be one and should be one. But both of them have emphasized, and there were plenary talks in ISSS back in Asilomar days, on the concept of evolution moving away from Darwinian evolution to cooperation as well as competition. And in fact, Darwinians have responded by saying, oh, Darwin talked about cooperation too, so it's not as stark a difference. However, competitive exclusion became the mathematical, I think bioevolution has kind of relied on competition more. And that became, of course, a cultural thing with Darwinian selection in terms of genomes and so on, and it drove eugenics and so on. But look into the several books by Peter Corning where he emphasizes cooperation. And don't forget Synergetics of Herman Haken. I don't recommend the books to you. He's done 123 in the Springer series in Europe, but all of them actually emphasize certain of the isomorphies, and his word synergetics really implies general systems theory. It's basically the same thing. It just that he doesn't call it that because he's doing his own thing. And most of his books are so mathematical and so based on physics and mathematics that I think they're mostly inaccessible to the general systems people. Anyway, I take note of your need for discrimination between evolution, emergence, and development, and Lynn's too. And in fact, I've written papers on that in the ISSS proceedings before. I don't know if I can find them, and they're not on the Len Troncalli workspace or website, because in many of those, I'm actually retyping them in because they're such a mess when we scan them. And I hope to continue that work in addition with the pamphlets. Did I send you guys a list of the pamphlet titles? I think I did to Lynn. I don't know if I did to the integration squad group.
Sure.
And George, they also arose out of the outlines I made for Springer, which I never sent in as a proposal.
I think I saw the list of titles. It looked very long. I think there was one that I wanted to read long before the others, but I can't remember which one it was now.
Well, that's why I did the pamphlet series, so that people could pick out one they were particularly interested in from the title. And now with the one-page précis, that'll be even easier.
Yeah, excellent.
I wrote Len also the one or two that I would want him to see and do first. I don't know if he's going to follow any of us, but
Well,
so,
you know, one thing that's
go ahead,
come
Jim.
up for me in writing two, I guess you'd call them textbooks, specifically about system science, is the need to cross-reference, because no one principle, say, or no one subject actually stands alone. So I don't know, Len, how you plan to do that other than, and I think you're going to find you have to do it, other than, you know, well, buy my other pamphlets.
Yeah.
And you can read about this subject.
Okay, so let's let Len work that out. I think that's appropriate comment of the.
Well, I've finished the first pamphlet, and it has many cross references internally and to other pamphlets.
Yeah.
That's a problem, though. Yeah.
And you have to do that. That's true in the systems sense. It also provides you with what I call network reading. So you don't have to read from page 1 to page 500. You can jump around. And that's why it'd be especially good if it were digitized, because then they could jump directly to something. You could put the URL there for them to jump. Just follow those choices.
So I do have a couple more, another question, but I know Hillary texted, you chatted, Hillary, that you would like to make another comment?
Yeah, I wanted to pick up on something that Tom said a while ago. The business of, I'm a total heretic about hierarchies, because every time I start looking at particularly a systems problem, you find that you can just keep climbing up in several different directions. So there isn't a single containing system until you get to the universe. And according to some physicists, even that's not a valid containing system. And the point is, it's often not necessary. And I think for what we're trying to do, which is I suppose effectively discover domains for which there are different alpha kits and then see what's in them. I find it much more compelling when we can trace these are the systems that had to be present before that one could come into existence, than that contains that, because the containment hierarchy only works for, okay, you only find lungs and hearts in a certain subset of biological systems. But when you start saying what exactly is the world, for example, are we subsystems of the world, or is it subsystems of us? And actually those questions matter a lot if you try to impose a hierarchy on a system you don't fully understand yet, and they don't matter in the slightest if you don't try to impose that hierarchy. So I would advocate in the modeling that we're doing, forget about containment hierarchies and just say that's the necessary precursors of that system or that kind of system were these ones. And that actually gives it, that should let us gradually build up I suppose it will be something a bit like the geological strata of the different scalar levels and the different dynamic realms that they lead to. Yes, I'm from long experience in engineering, when people have got themselves totally messed up by thinking they understood the top-down hierarchy and didn't. I would advocate allow that to emerge from the work rather than try to impose it. But every time we come back to that and that and that had to be there before that could come into existence, and their complexities had to co-evolve, I find that a much more satisfying and convincing route to some sort of framework than almost imposing a containing system on stuff when we don't need to.
I want to make a comment to that, Hillary. I once sat in on the PhD students for Tim Allen and his ecology studies at in Madison, and they met every week for what did they call it, the playground or something. They called it to talk about their projects. Yeah, they talked about their projects in ecological studies. And in his books, and he drives me crazy, and I know he drives Len really crazy. But what he describes, you can't describe subsystems of an ecology.
Yeah, exactly. Yeah.
It just doesn't break down like that.
Yes.
It doesn't work like that.
Yes.
So he goes farther to say, that hierarchies are human constructions. I disagree.
I agree.
I disagree with that. What he does say properly is identify the system of focus, then identify possible subsystems and the supersystems, and then you've created a hierarchy. Then you can do it. You know what I mean? But then understanding that you're picking out particular subsystems sometimes in an ecology.
So that picking out is a human construction. Therefore, hierarchies are a human construction.
Exactly.
We only find hierarchies when we try to simplify the description of something.
Okay, hold on. I disagree.
Exactly.
I know.
I disagree too.
Having done it personally on several occasions, these things do. You have to identify what the relevant, say, variables are. But if we take an ecology, an ecological system, we call it an ecological system for a reason. And if you do something like look at the food chain, what am I trying to say? The stuff that Howard Odum used to do. You very quickly come to sorts of hierarchies and subsystems and so forth. So I think the problem is having too narrow a view of what we mean by that word hierarchy. And I think that may be problematic. But those interrelationships that exist, trophic levels, that's what I was trying to.
Okay.
They do exist. You have to know something about ecology and something quite a bit about biology in order to be able to identify, but you're not constructing those things. They're there. That's how they get along without us.
Yeah, but nonetheless, in that case, I agree. You have identifiable trophic levels, predator-prey hierarchy, and those exist within areas of study. But you define the area of study, and
there's a lot more than that. It's the these ecosystem is a lot more than that.
what's that? Can you hear that now?
Yeah.
Sorry, my batteries are dying. I think I'll switch back to internal speakers.
Yeah.
Okay.
An ecosystem's got an atmosphere, and in the case of the fish and whales and things, which where we often see these trophic levels, you've got the water and you've got a whole lot of other things that are involved as well. And when you define a limited scope of study, then yes, you can find a hierarchy within that. When you're trying to understand relationships, yeah, as I say, I still have this issue that, as Lynn says, whole ecosystems don't work hierarchically because you've got you've got cyclic dependencies on them. So once you start having cyclic dependencies, you haven't got a single unique hierarchy that applies to more than one topic of analysis, I don't think.
Well, I use
It's certainly not
energy.
necessary to impose it for a lot of things. You need to discover it rather than pre-impose it.
In
And
my
the tendency
ontology,
in modeling
energy is
to pre-impose an assumption, and then that limits the way things develop.
in my ontology. I start by
George, you're in mute, apparently.
no.
No, I heard him. I hear George. George, you're
So,
fine.
okay. In my ontology, energy is a primary, substance. So energy flows are basically what I look at. And that's why I bring up the trophic levels, because you absolutely can identify different levels of power being used at the different levels within the trophic levels. So if you start from that, and I try to explain, this ontology is a set of commitments being made in order to start to unravel what's going on. But you can do this, matter is the same way. You look at the material exchanges that go on at different levels and so forth. And once you do that, you have found the means for identifying actual boundaries. And they may be fuzzy boundaries, but that's okay. Anyway, that's
good. So we only have about 13 minutes, and I do want to jump in for a couple minutes once more. Although sometimes we go a little bit later, but sometimes it might be good to try to end and make a plan for next time, perhaps. So I want to say I really appreciate Len's use of the term dynamics, that there's new dynamics at each of these big E's. I'm very much go along with those lines, even though, as Hillary said, I have these things on the dynamic realm, and I'm still wrestling with the fact that every level, at least in my scheme, has something new in terms of dynamics, but sometimes major new dynamics come in, big D or something like that, which I'm still wrestling with. But I like the term very much, because I think that can encompass a lot of things. And I like the Helen, your search for a word like affordances, communication. I'll just say I'm perfectly comfortable with the word relations, because I think it's broad enough to encompass physical, biological, human, and I also use it to mean both real and potential. And I like that as a concept to kind of lock in, that there are current relations that these things have, these new emergent things have, and there are potential relations that it may take some evolutionary time to open up those relations. But I like that. I like Len's discussion about it's the potential fields that give rise to the diversification. Len, I'm very much on board with that as a major concept. Here is where I think there are still some issues. When I first started to write a follow-up book for meta patterns, I thought, wow, a fundamental pattern is the existence of parts in wholes, systems. But I thought, then pretty soon, there's no way I can take that on and have that be a scalar metric, because it can lead to almost anything. It can lead to the entire universe, which gets us into the problem that Tom brings up, that you're going to try to one has to classify to model everything. So I wanted to set up some scheme that I could just run it, and this is where I like Len's word scalar, as meaning measure. I didn't quite get that the first time. Scalar, something you can measure, but it doesn't have to be quantitative measure. It could be like a topological. I'm okay with sort of a topological metric of some kind. And that's why I eventually concluded that if I went from small to humans, I've said this before, through merger and integration, or combination and integration, I was comfortable, I could set that up and then ask the universe, so to speak, what the levels are, to try to get out of the subjective as much as possible. It's not possible, it's not totally possible. I set up that logic but I did want to run the logic. So here's what I think I still don't see with what Len presented today. That the question becomes this issue of the new dynamics, and some of you brought this up as well. How and Len said he's not going to restrict it to mergers from small to large. He did say that today. Where do we draw lines? Len started talking about the rabbit hole of the kinds of bodies of water that exist, rivers, lakes. And I wrote down where do we stop? Or to get into the internal of the earth, is mantle and lithosphere, do we concern ourselves with those, or do we just concern ourselves with what it takes for a planet to have plate tectonics? We can have stars, but now it turns out colliding neutron stars might be giving rise to some of the rare earth elements that might not get born in stars. I do support Len's idea that we got to keep going into the peer-reviewed literature, but I want more than I don't want it to take 100 years. I want to see something happen, in my life. I want us to see something happen in the next year that papers can get published, or books can get, we're all working on things. So I guess I'm still left with the question of defining of the characteristics of this big E. I'm happy with it. I'm happy with the quest for new scalar levels of new corporate plans that have new dynamics. I'm happy with that. I'm happy with Len's system process called central stability, because he said it's basically the same as the new corporate plan. You're not going to have a new corporate plan unless you have something that makes that corporate plan hold together. I'm happy with some sort of concept of peripheral stability, that there's variability that happens in these levels. But what I'm not still happy about, in the sense that by happy meaning, can we set up the logic and then let it run? I don't think we're there. I don't think we're there, because when we get into the issues of subspecialization, and I think somebody said, like, heart, lungs, liver, do we lump all those things into organs? But then some multicellular things have tissues. So I don't, unless we can say what's going to give us, I'm going to leave it at that. I think you're getting my drift, that I don't yet see a logic that we can set up and ask reality and to be able to spit out these chapters of a sequence. I'm all for the plan, unless the only thing I can see so far is that merger of pre-existing things into new things is something I feel comfortable that can be set up, but I don't know if it can be done with subspecialization, and I don't know if it can be done with the macro environment, even though subspecialization is crucial to the universe, and the macro environment that creates coevolution at all these different stages is crucial to the whole structure of the universe. What I would love to see is proposals from people that we could review in this in this meeting. And George, I know you have energy in there, but I haven't seen it that I could say yes to without seeing some peer review discussion about it when I've seen it in these meetings. So that's where I'm left at this point. And maybe I'll pass it back to Len to do some final comments, or to see if there's anybody else wants to say anything.
Well, I'm sorry that you still are relying on merger. It is the simplest and easiest one to ascertain. But I want to say something about heresies. In full disclosure, I'm a Roman Catholic, so of course we're totally against heresies. But I must say I'm not a practicing Roman Catholic, or at least I don't practice very much. In fact, if they knew me, they'd probably excommunicate me. So I keep my mouth shut most of the time. But Lynn Rasmussen is my heretic. I don't know if she responds to that, but Lynn and Luke, well, actually, Luke is a heretic too. At one time, I tried to establish the USSO as a thing that everyone could agree on. And obviously, I'm still not convincing everybody in this group. I hasten to add that I really believe in what Mobus and Tyler Volk are doing. I think they're making an overview that's more compatible with the audience. I think it communicates better. I think the title Quarks to Culture and Principles of System Science were very good, but
it's not
we're trying different purposes. We're trying different objectives, and the USSO, I tried to show you, has different objectives. And I want to get back to the heresy of Luke and Lynn. When I was teaching them in those courses, or rather learning with them, that would be a better way to put it. In fact, I kind of wanted everyone to follow the same ideas, and that's anti-heretical, and maybe came from my background as a Roman Catholic. But I have to say that the diversification part of the cycle itself requires that there be heresies, that you go away from a common integration and do lots of variations. And so I actually, in principle, decided that the heresies were better. And Lynn, when she tries to do the field guide, is diverging from a lot of my thoughts in terms of the isomorphies, although still actually agreeing with the isomorphic concept itself, but the views of the specific ones are different. And I encourage that heresy in both Luke and Lynn. Luke is heretical, even though he's the treasurer for the Systems Pathology Society. He actually is against systems pathology or conventional medicine, in essence. So I have to say that I encourage heresies because that's where the new synthesis will come from. And that's why I also encourage Tyler Volk and George Mobus. I don't call them heretical, but I call them doing different things for different purposes, and those are good. But you didn't seem to like that, Tyler. I thought
I didn't like. Well, somehow you were framing me. I mean, I can thank you for saying that what I was doing is more easy to communicate. But I just want to say I would rebel against any phrasing that I laid out the 12 because they were easy to communicate. I was really trying to run a logic that I could just let run and not be as subjective as little. So when you said the merger is easy to define, I do agree with that because I think that there's a scalar in the logical metric kind of way, a scalar way that can be said, it's easy to say yes or no to. I guess what I would ask you is how are we expected to do the big E's that are subspecialization big E's. Some of your big E's are mergers, right?
No question.
So some are mergers, but some are not.
In fact, one of the systems processes in the table is aggregation. And
so are you able to tell us what the logic of the subspecialization big E's would be that one would search for in the literature to determine them?
well, for instance,
Yeah.
the ones that you're wrestling with, I consider all cancers to not be organ cancers. There's not breast cancer and lung cancer and skin cancer and so on, or colon cancer. There are cancers of tissue development. And so cancer is really a tissue disease. It is not an organ disease. It's just easier to have specialists in breast cancer and prostate cancer and colon cancer and so on.
Completely agree.
But in fact, if you look at the organization that's in every biotextbook, it goes from molecules to organelles to organs, to cells to organs. It doesn't go from molecules to molecular machines to organelles to tissues to organs and stuff. In fact, the biohierarchy is wrong in many of the textbooks, and I can empirically prove that. Molecular machines, they just didn't have enough knowledge when they made their original hierarchies. The tissue concept that they just didn't understand. And tissues make it easier, Tyler, to relate the non-diversified eukaryotes to the eukaryotes. And you don't even have a concept of eukaryotes at all, because you don't understand the specifics of exploration that happen on the eukaryote levels, the molds and the, and those early multicellular types really started with development of the tissues. And so, I don't have time to explain all of that because we're at the end of our time, but those are very important insights, I think, for this whole thing. And basically what you've just asked me is, how do you incorporate, is this correct? How do you incorporate the subspecialization parts of the hierarchy?
Big E's that are subspecializations, big E's that are part of the macro, and big E's that are mergers. Because I think you have all three of those types of big E's in your schemes.
Right now I do, because, it's not done.
And I'm not saying you shouldn't, but if they all have big E, I do agree they all got to be new. Okay, so they're all new, but then you into the issue of how you're going to scalarly define them in a way that we can carry out the logic. Like you said, your new seven exotic systems processes, some you feel more confident about than others. The counter parity is still hypothetical. So you're not, or it's hypothesis. So you're not yet using that as a criteria you're not going to say no to some big E because it does not have a counter parity yet. You're using it to say, we may let us search for counter parities and see if it's true at each big E, but you're not using it as a crank the logical crank of counter parity to define the big E. You're kind of using them in a feedback way, counter parity and big E. You're saying, I can define big E, maybe, does it have a counter parity? But if it doesn't, I'm not going to throw it out. So you're not using it as an absolute in-out criterion. Am I right with that?
Yes, I think you're correct in that. Mhm.
So Helen's leaving, and people are probably leaving. I don't know. Personally, I'd like to continue with this line of trying to go with developing a logic that we think we can be cranked. By crank, I mean like apply it. And
Well, I think you said it pretty clearly. You want a logic that left on its own would generate everything.
Yes, that then we go into the science and we can say yes or no to things. I mean, there can be blurry areas, but I see. Okay, George has his hand up.
Yeah, that's actually what the ontogenic cycle is about. It's Helene. It's essentially saying that you apply this logic. It goes through this, the combogenesis part, which I've been calling auto-organization. Then that's whatever comes out of that, whatever combinations come out of that, are subjected to the environmental conditions that are extant around those new things. And then some of those are going to work out. They're going to be stable, but many more are not going to be stable. And so you just keep going around, and that's where emergence comes in. The ones that are stable, I'm saying that's the true emergence, the big E, if you will.
So we could do like a sort of a squad review of. I know we did once, George, but we didn't sort of focus on it. I think the whole time. We could do squad review of you do a proposal for Big E, for your version of Big E. I don't know.
I must say that the theory of emergence mechanism, combogenesis and ontogenesis, have a lot of similarities to them.
Yes, totally.
And those are all the logic by which you could set free any one of those mechanisms. Is the logic that you could step back from, and the world would generate itself.
I don't. Yeah. Go ahead.
I want to make since I've really looked at all three of yours pretty intensely. I would say what needs to happen is a real concentration on what George concentrates on, more the processes, Len too, and get away from the actual, the list of what was actually produced out there, the endless list of complicated things. And let's talk about more specifically and compare specifically the individual processes that produce this emergence. And I mean, I could argue very easily that this emergence is just a scalar thing. You're looking at the big one, Len, but it's happening right here, and emergence is happening right here in this conversation potentially. I mean, it's just like, I mean, I'm talking about, you know, the constant production of things and the activity of information with that and the meaning of information with that is huge right now. I can't even discuss things without discussing information and the formation of things and new levels and new scalar levels. It's just, so I'd like to actually nail down what are the processes of, and Len, you've got all these new processes. I could argue some of those new ones are just, you know, the same old ones we've had. If we stop looking at scalar levels. You know?
One thing I want to point out, well, there's two things actually I want to point out. One is that what I've been calling auto-organization is actually, in my view, it's a very dynamical process. It's not just things coming together, but things coming together, splitting apart, coming together in new ways and so forth, until some stability is reached. The other thing is that in every single one of those, what I've been calling levels of organization, once something exists and it's become stable, that doesn't mean that it can't actually acquire other little things that were components in the first place. So that's the diversification that can be occurring.
Mhm.
There's no point at which we, you know, chop it off and say that's well, the process, but it just keeps on going and can keep on going after that.
Maybe we should go into this more, George, because as I remember, when you would show the diagram of your energy in and waste energy out, the issue kept getting kept arising on an atom, the stabilization of an atom. And then you said, well, that was in the formation of the atom, the energy transfer happened, but the atom does not need energy transfer, you know, after that. So in a way, I would almost like to go into that more, because I wasn't sure how you're going to set that up again as a logic you can crank to determine, to let the world determine your levels, since you're going to ask different questions about energy. It's not, so that one diagram was not the only diagram. I mean,
no, there's several in that chapter. The other thing I wanted to, actually I did. The idea that once a big E occurs, and I'm just now adopting that language, it doesn't mean that that's the end of auto-organization per se, because you can still have, like I said, there's still particles out there. I'm not using that in the sense of fundamental particles. I'm saying in this cycle, the things that came together to make some bigger thing, a lot of those things are still available, and so can come into and out of relations with that bigger thing. And that's where I think diversity comes into the picture.
That's the argument of Evo Devo. That's the Evo Devo argument right there. That development is never a clear cut, yeah, it's following DNA, but you know, your genetics, but we're all different and it's always changing. There's always diversity. Yeah. And that's the beauty of genetics is that, and getting together, you know, two pieces of DNA into one human being is a huge possibility for diversification. And then that just diversification, of course, we see it right in the human race, you know, starts to, you know, what's stable, what isn't, who reproduces.
So ontogenesis operates at all these different levels, and that's the common logic that I'm saying. When you look at the things that are in a level, you have to look at them for their specific affordances. You know, what kinds of potential bonds can they make to make the next bigger thing? What kinds of relations can they come into?
But since everything has energy, and this is getting into Georgia, maybe this is the topic for next time. Everything has energy. Energy is a common currency for the formation of everything. I guess, George, I would like to go into that more, because again, which things are not going to go in your sequence, or which ones are? How do you use that metric to develop? I guess I want to see these. I guess and even with Len, I guess I almost want to see, okay, let's propose the sequence and let's go through it step by step. I mean, if there's a sequence of 35 or 40 things, even though we started off with Len being a work in progress, at some point, if there's 35 or 40 big E's in a sequence, man, I want to know them. I guess I want to know them, just for my own understanding of our universe, Len. If you're still there.
I think Len's.
Yeah.
I
agree. I think I said this right at the very start. I'd really like to go through the unbroken sequence of origins and unpick the actual processes that are taking place. Yeah, Because I think within integration and within diversification, there are sub-processes depending on the particular context of the emergence. And by looking at those sub-processes, I think we will be able to start classifying the different types of emergencies that are taking place, you know, whether they're within the scale, whether they're creating a brand new scale, whether they're specializations, which sort of drill down.
Yeah.
Yeah, so I really do think that that would be a valuable thing to do, but yeah, just time and, you know, and just getting us all together to do it. We should lock ourselves away for a month.
I guess I want to see peer review of actual now proposals, because you've heard mine. George has talked about energy. Len's now talked about his general today, but maybe see specific proposals. And George, you did say you got these dashed lines that like you're not saying there aren't things in that dashed line. So that's obviously, you know, very, very good in that way, because you're leaving.
Well, what my approach was going to be, or is, and it's in the book, is that I describe the ontogenic cycle, the fundamental mechanisms of it, and then apply it at sort of sampled points in different systems at different scales. And if I can find the mechanisms, those ontogenic mechanisms, in the origin of those things, then this is legitimizing the notion of the ontogenic cycle.
Yeah.
And then that being the case, if that's the case, then that cycle can be used as a template or a pattern that tells us what to look for in other areas that haven't been studied in the same way.
Yeah.
And that's where I apply it to the human social system. What does all this mean in terms of where humanity goes?
Yeah. So,
Oops.
yeah.
Sorry.
What I'd like to suggest is that, you know, we've invested a lot of our time and our conversations and our effort into starting to develop, you know, a common understanding of where we're all coming from and the different languages. And I really do think that we are now adequately equipped to do what you just said, George. Yeah, to take your model, examine one particular point in the unbroken sequence of origins, and use your model to unpick, you know, that particular situation, and to drill into, you know, what actual processes are taking place and how does that relate to your model.
No? Sounds good. I wanted to bring up one other thing if we got a little bit of time. It's my sense, well, Tyler and I have been contacting other people who were along very similar lines of thinking. And I'm beginning to build this sense, and Peter Corning was mentioned earlier, beginning to build this sense that maybe it's time for some kind of a workshop. That we invite more people in and try to get, not just get more perspectives, but each of us maybe get some ideas and look for larger patterns of agreement and so forth. So I'm not thinking about just expanding this group incrementally, but rather to actually open it up, have a very definitive, and Tyler's, you know, basically framed it very well, have a very definitive objective for a workshop. And then people will have to do some homework, have to read everybody's papers or books before actually going to the workshop so that we can have some meaningful interaction.
But how about we do that as a second step? You know, we do what you first suggest, which is focus on one particular thing, yeah, in the unbroken sequence of origins, and compare that to the ontogenic model. So we do that first.
Oh yeah, I'm not saying that, I'm not conflating those two ideas.
Yeah. Because I think once we've done that, we would be adequately equipped to provide a structure for a wider workshop.
Yeah.
I think we really need to drill down. And I'm going to look at this, at the difference between the ontogenic cycle, lens thing, evolution, new conceptions of evolution and development. We've got to look at, you know, Tyler's points in combogenesis. I mean, there is some really, I think we can drill down. Now, a workshop would require, we're all starting from someplace now. Do you know what I mean? And you're right. You know, you'd have to have reading materials. Nobody ever reads the reading materials. What we'd have to do is have come from a common, okay, here's where we're all starting, everybody, and have a paper on it or something. An introduction to this, this workshop, maybe a plenary talk or some kind of way to tie everything. This is this compared to this, compared to this, compared to this. And then have maybe open discussions. I don't know, it's interesting.
I do think we should drill down into specifics, but this group already has enough. We are in a sense a workshop.
No.
Yeah, and I can't do 2 days of time right now for like.
No.
I mean, there'd be Peter Corning. Somebody wants to invite Peter Corning. He's got some new papers out. He's got a book coming out on the future of human society. He's applying his symbiosis stuff to synergy stuff to human societies. I mean, there's a lot of people out there, but we're a really interesting group already as it is. I guess I'd like to see next time, and I hope we can get Len involved, is to do George's. And even though, George, you've talked about your diagram, you've shown it multiple times, I think we should try to have some peer review of the individual items in your scheme. It's more than I have in my 12. It's less than Len's. Len's not willing yet to show his 35 that we can go through and really have critique about, but you might be able to have us do some review of your individual big E's, you know, if we use that language within this group. You have big E's that are in about like 2 or 3 diagrams, if they're, you know, if you put them together in your book, and I've looked at them. I don't know. I mean, how do people feel about that going into individual?
I'd like to see that.
George's.
I'd really like to do that. I'd like to really look at George's now that we've heard Len.
Yep.
He didn't organize. I wanted to see some kind of organized approach to the actual process. You know, and he did give us some really good background, but I don't see a chart. You know, I don't see what Len gives, what George gives us.
Yeah.
I want to see a diagram.
Yeah.
Yes.
And he's given us the oscillating diagram, the old one.
And he's not willing. He wasn't willing to defend everything in that. And I know George and I have sort of privately emailed some issues that we have with particular. With particular steps in that, but then as he stepped back and said, "No, this is a research; it's work in progress." But George is maybe willing to show those new things, the new corporate plans and his diagrams, and talk about them one by one.
Well, as you guys know very well, until you've put your foot to the fire in a book.
Yep.
Really easy. I'm serious.
Yep.
It's really easy.
Yep.
To say anything you want in a bunch of power slides that change every single time you talk.
Yep.
And it's not that it makes it less interesting or valid or anything. It's just, well, it makes it less valid in that you haven't put your feet to the fire and made those connections and defended them.
Yep. And
when you put it in writing, then you've got something that people can critique. And you ask for the writing and the slides. The slides have some stuff in it, but again, I'm saying, okay, there are all these his neologisms, you know. I'm just going, sorry, that's not enough for comparison. It's not there.
So we're hearing from Len, me, and Gary, George, that we'd love to go through yours in detail in the next
Please.
meeting.
Very
All
much.
right.
Really appreciate that.
You know, I've already started that work, and I was gonna, I think, put it in an appendix to the new book. So I'll just dig some of that. We won't be able to cover everything, but just sampling
Yeah, yeah,
you.
yeah. And when
Well,
you,
but why can't we? It's only about 20 things, right? It's only about 20.
An overview.
we'll
An
go,
overview,
go big and then go deep. Yeah.
Yeah, I know you're doing a thing like with the carbon dioxide molecule, but that's not quite what we're talking. I think we're talking about the your major big E's. You know, how do you see the what would you propose as the
Yeah,
big,
I'm trying to find it actually. Hold on just a minute.
find it for December?
I'm tripping out. If you're looking, I'm tripping out on all this stuff today because I'm just going, wait a minute. I've been writing about networks and hierarchies and distribution, parallel distribution in such a basic way. Such a basic way. And fractals, you know, and I'm just going fractal. Len said today, hierarchies are fractals. Yes, absolutely. I mean, fractals are hierarchies. Fractals form through networks. And now I'm looking at this and I'm going, okay, this is a network effect of distribution. And it's the same old thing that happens in NetLogo, that for the production of new things. It's just really basic to me. It's becoming so basic. I'm going, no, can this be true? Do I need all these fancy terms, Len?
I mean, because I'm always like sort of buzzed for a couple days after these Saturday meetings. So just I just looking at the notes I took and like, wow, I want to write this, but I want to write this, and I get back to work. I'm still at NYU, but I definitely spin for a couple days from these.
Well, see, George is, like I said, George has been putting his feet to the fire and writing it. When you write it, and your writing has evolved you, right, George? That yeah, obviously. I mean, I'm trying to keep up.
Yeah.
And
let's do George's set of big E's. I mean, because I'm willing to defend my 12, and I did in the book, and no one's giving me any like huge objections to them. They just say, well, but you didn't include this, you didn't include that. But I didn't need to. I wasn't trying to do.
No, I love it. It
did the job
perfectly.
It's about the process.
Right.
It's not about the particulars. It's about how did all that happen.
And I knew it wasn't going to include everything, but George and I really see eye to eye. His is more general. So and you know, George, we've had some discussion about parts of it, and the use of that diagram doesn't apply to the atom unless you hand wave about that diagram. So is there a diagram you want to stay with that develops your big E's? Or
now, are you talking about the cycle diagram?
Yeah, the diagram that needs energy input all the time.
Oh, no.
Oh, the ontogenic cycle diagram. That I'm basically okay with because yes, that.
See, the whole
very
point.
Abstract. Your ontogenic cycle diagram is very abstract. I basically I think I agree with it. I think I remember it and I agree with it.
Yeah, it takes energy to do work of putting matter together, right? And
no, it doesn't take. It does not. I object. It doesn't take work to bring an electron into an orbit of a proton. It can produce work, in fact, because, and that's what I don't see eye to eye with you yet, because I don't see that. I disagree with that statement.
So you discount the idea that an electromagnetic force field is not able to do work because it's changing the momentum.
No, but it's the energy repose. The difference between an energy repose system and a system that needs energy input, like a living cell.
Right. No, I differentiate between those two.
Oh, okay.
That's where I go back to the whole subject matter of phase transitions. And
Yes.
Smith and Morowitz's idea of the phase transition that accounts for the origin of life,
Right.
being that boundary that we go over. Now you need a constant flow of energy. Whereas before, an energy event occurred. So it doesn't have to be constant.
But to bring electrons into a nucleus, there's nothing you have to overcome. That particular thing.
The momentum of those particles, yeah.
Oh, man, but the electron is a wave function that. I'm not sure. It's not the same.
I surrender. I surrender.
But let's do George.
I can't take any more.
Yeah, okay. Time for a beer, Gary, or wine or something.
Yeah. And one thing I'm going to do, and if you're going to do that, one thing I'll look at, and because I'm going to have to kick in on it somehow and compare it, is I'm going to look at Kaufman's new book again, his Generation of Life, that little piece from this one paper. It's pretty fascinating.
Lynn, I didn't tell you, I thought that book was one of his best yet. It's sort of summarizing a lifetime of work.
Yeah.
But I think he made a really fundamental point about the difference in biological systems from physical chemical systems.
Yeah.
That one can talk
about. He made that little leap with that set of little equations. And man, that's really interesting stuff. And I think it very much has something to do with all this. And I have to put it together. And I don't agree. Yeah, I went into some of those papers of these French young people or Swiss young people he cites highly in that book, and I'm not really convinced with that yet. But anyway, I do agree. The book is really well written, readable, and does make some big points. I thought the title is good. Beyond the world beyond physics. Things I really agree with. The word function comes in. Anyway, it's that absolute paper that he really focuses on. I can't remember their names, but I'll write it up a little bit in some kind of form to make it simple in a one-pager.
I guess in terms of a squad peer review of my stuff, I guess one time at some point, and maybe we can do both at once next time, I would like to go through the human parts, what to me are my level 10, 11, and 12, because they're the parts that I most, because humans are always processing energy and always innovating. Why did I define the human meta group, the agro-village, and the geopolitical state as 3 new levels of combogenesis? It's at some point, rather than people saying they've read mine, I would almost like to present my own logic and my own maybe uncertainty about some of what I did in that.
Let's do George next week and then do yours
in January
following, because
that's fine.
Because I think from George's we can explain yours.
Well, maybe during the holiday session we could have a special edition, where we go at this for half a day or something. Yeah. Yeah. Well, we're all on holiday. Yeah. Maybe we can find, because you're not going to be going anywhere, are we? So, yeah. Maybe we could have a half day.
I hope Len stays with us, of course. I totally hope he always threatens to quit and then comes back.
Oh, he always does that. He always does that. Don't worry about
it's a cycle. It's a cycle. Okay, I've really got to go. But thanks.
You.
This was great. This was great again. All right.
Yep.
Take care, everybody.
Thanks so much.
You too.